Hello. So the problem today is search suggestions system and how to do this and how to solve this problem. So basically the problem is that we have, this this vector of strings and we have this search word, and essentially each loop we want to be able to um, return the first three words that are most relevant to the search that we're coming up with as each character of this search word is being typed. So in this situation, for the M, we'll return this mobile money pot monitor. For MO, still same three. MOU, it changes to a mouse and mouse pad, and for the whole MOUSE to mouse and mouse pad. And that's because the moment we add the U, you can see that it's not within these first three characters of that of these strings. So how to solve this is basically, just the way I just described it, right? You want to go through each character and check, is it a part of it? If it's a part of it, and if it is, then we'll add it to that vector of um, vector of strings. And first, before we do that, notice how these aren't sorted, so they aren't alphabetized. So when we're going through each one, it might make things a little more difficult to go through, because once we get through these, right, these are sorted and alphabetized. Once we want to disregard them, we don't want to see them anymore. So for an example, right, if these weren't sorted, and we were at this mouse, we would want to keep mouse because it's literally the exact same thing as that search word. So by sorting, we can eliminate the words that we don't want, and the way we can do that is with two pointers, a left pointer and a right pointer. So the left pointer would be at the beginning, the right pointer would be at the end, and we essentially just work our way down and up until we get to that trio of words that fit our criteria. So first thing to do with any problem is to just initialize our result. So our result, again, as you can see, a vector of strings. So we do vector of string. I'm just going to call it result. And then from there, we're going to sort our product, our input. So sort from the beginning of the product. So products dot begin, and then products dot end. So now we have a sorted array, if you will, or sorted vector. Sorry. And now let's initialize our pointers. So left is equal to 0, and then right is equal to the end of this. So products and size minus 1. So the last indice. So we'd be right would be pointing here, left would be pointing here in this case. Right now, we can essentially loop through each character of this search word to try and find our accurate results. So let's search through each one. So I equals 0. Oops, I forgot the I. I is less than search word dot size, and then we'll increment up. So we'll be going from 0 to 4. So 0, 1, 2, 3, 4. So that's all 5 of the letters that are in this search word, at least for this case, right? Now, what we want to do is essentially from here, we're going to be checking, and we want to find or invalidate every word that is not needed when we check each character. So we can start with the left pointer. So while L is less than or equal to R, right? That's obviously we don't want the left pointer and the right pointer to be crossing each other. And this is where we find out what's in if the word is invalidated or not, right? The first thing we're going to check is this ith character that we're looking at. So let's say we're looking at like E, and you know the word is only like 3 letters long. Are we out of bounds of the word we're looking at? So the way we could do this is by looking at the products at indice I dot size. Is that less than or equal to the number we're looking at, that letter that we're looking at? If that's at, you know, letter 3, is that more? Or, right, or another way to see if it's invalid is by seeing, I mean, is it even a part of, is that letter even a part of it? So in this case, right, is U even a part of this word here? So in this case, right, it's not. The B is. So, or is products at, oops, sorry, I meant to say L, not I here. If products at that left pointer and at that indice, is that even in the search word, right? So search word I. So is that, again, we're saying, is the left pointer less than the right pointer? And as long as that is, we'll keep running. And if one of these two conditions are met, if it's invalid, so are we still within the size of the word? Or is this indice, is this word letter, sorry, even in this word? So if it's not, then what we're going to do is we're going to increment up by 1. And the same thing is for the right, except instead we want to decrement down. So this just should be R, and that should be R. So then we'll decrement down. So now essentially what we're doing is each round for each word, we're basically removing any unneeded words. So I'm just going to quickly run through this just verbally. So for the first one, for M, right, we're going to check, okay, is all of these words valid? Is each pointer valid or doesn't need to be moved? And in this case, like on the left side, it's valid. On the right side, valid. We don't need to move it. Okay, let's go to O. Same thing. They all have O's. So even if it was, I know this is the unsorted list, but let's assume it's a sorted list, right? They all have the O. Now when we get to the U, though, in mouse, so this part, right, that's when things start to change, right? We look here. Okay, no, there is no U. So then we'll move on to the next one. Alphabetically, I think it's this. So then we'll see N. No, move on. N. Oh, okay, those don't have U. So we'll go to the next one, which I think is mouse. Okay, that does. So now the left pointer would stay here. And then on the right pointer side, it doesn't need to move because this is the longest word alphabetically. So we'll just, and since it's still within, and then we keep going. And then for SE, right, mouse and obviously mouse pad both have that, so we don't change that, and we'll just push those values in. So now that we have our left and right pointers initialized, right, we need to, for this round, for that specific letter, we need to, we need to put them into a vector and push it into our result. So I'm going to make a temp vector. So vector of strings, right? Let's call it temp. And then essentially we have a problem, right? From going from here. How many strings do we put into this vector? The max we can put is 3, right? However, if in this case, right, the only two that are left is mouse and mousepad. So how do we determine how many do we need to put left, right? So we can find out how much is remaining. So I could do remaining, right, is equal to the minimum. So it's either min of either 3 or the difference between the right minus left plus 1. So let me put these in parentheses. So again, let me just reiterate here what's going on, right? For the first round, right, all of them have m's, right? The right would be here at 0, 1, 2, 3, 4, and left would be 0. So this would be 4, this would be 0. And what we're doing here is we're doing 4 minus 0 plus 1. That's 5. And then we're comparing that to 3. So obviously 5 is less or bigger than 3, so 3 would be our remaining. And you know, when we move down to one is just, let's say, mouse and mouse pad, right? They would be at 4 and 3. We would do 4 minus 3, that's 1, plus 1 is 2. So we have 2 words left, and that's obviously smaller than 3, so that's what our remaining would be. So now we want to loop through that array, or through the this vector for the minimum amount of time. So the most would be 3, right? But in this case where there's only 2 left, we'd only have 2. So I could just do int j is equal to 0. J is less than the remaining. And now I do plus plus j. So what I do is I do temp dot push back, and what I want to do is the products at, I want to do the products at the left pointer plus the j, the indice that I'm counting up at. And then from there, I can push that result from the temp into the main one. And then that should be it, right? And then obviously outside of the for loop, return res. I think I'm missing somehow a parenthesis or something I deleted. So now when I run this, I can see that the case is passed, submitting it, and there we go. That's the solution.